Hello everyone. In this part I will talk about the relative motion analysis, the velocity. So if we have a general plane motion, so what it means is that it is translation with a rotation. So if we have a translation with a rotation, we can separate it into two parts. One is that the body is in pure translation. You can see that it moves in a purely translation manner, and then when the translation finishes, the body rotates about the point A. Okay, so it is like you are separating the motion into as if the summation of two parts. One is the pure translation, the other one is the rotation about the base point. It's also called the base point A. And then for this chapter we will use two equations. One is the velocity of B will be equal to velocity of A plus the velocity of B with respect to A, and we will use the velocity of B with respect to A is equal to the omega into the R B with respect to A. And then that B with respect to A is that the distance from A to B, we can say. Okay, this is so let me add a small note here. RBA is like the radius of circle S rotated that will be located at A, and then B rotates around A. Okay, that is what RBA means. Okay, let's move on to the problem statement, and then I think things will be easier when we solve on the problem. So we have a slider block C that is in the position shown. You can see it moves up and down, and then it moves the link BC, and then B also is constrained by the pin A. AB has an angular velocity of 2 radians per second, which is clockwise. And then determine the velocity of block C at this instant. What is the velocity of the block C? So omega is clockwise for AB, and that is 2 radians per second. Okay, clockwise omega is a negative. Okay, that's the convention. Okay, so we will do this way. We will first find B with respect to A, then C with respect to B. Velocity B with respect to A, then velocity C with respect to B. The reason is that A doesn't have velocity, it is 0. Therefore, it is easier to find B, and then similarly, if we find the B, we can find the velocity at point C. Let's do that. So I will first draw A to B. That's A, that's B, and that's the angular velocity of 2 radians per second. And then velocity B is equal to velocity A plus the velocity B with respect to A, which is omega into r into BA. Omega into r into BA. Okay. And then BA, this is the BA. Okay. It has two components. One is here and the other one's there. Let me just show the components of. Okay, that is RB with respect to A, that's X, R with respect to A, that's Y. If you check it here, so that's 45 degrees. Okay, that will be, this one is 15 inch, 15 into cosine 45, and that will be 15 into sine 45. Okay, and then I know that cosine and sine are equal, that's 0.707, that will be 15 times 0.707, that's 10.61 inch, and then 10.61 inch. Okay, so this one is 10.61 I plus 10.61 J. You can see one is in X direction, the other one is in Y direction. The omega is negative, and then body is like rotates around the Z axis. Okay, so B rotates around the Z axis, but negative. Okay, you can check by cross product, or let me just tell it as the right hand rule, that the omega of A B is negative 2k. Okay, negative 2 because it is negative in k direction. Okay, that will be negative 2, and then velocity of A is 0. Okay, because A is constrained. And in that way we can find the velocity of the point B. So let's do that. Velocity of point B will be equal to negative 2 times, okay, so let's do it this way. We have I, we have J, we have K, and then K into I is J, so the velocity of B will be equal to K into I is J, so that will be negative 2 times 10.61, 21.2 J, and then K into J is negative I, that will be minus 21.2 I. That is the velocity of the point B. Now that we have the need to find the velocity of C using the velocity of the point B.